Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify the product configuration. The product shown is 2-methoxybutane. The wedge dash drawing shows the central carbon, C2, with OCH3 on a wedge, coming toward viewer. Et on a dashed wedge, going away from viewer to the left. Me on a plane bond to the right. H at the bottom, in the plane. To assign configuration, OCH3, wedge, front, et, dash, back, me, right, plane, H, bottom, plane. Priority order, OCH3 at me H. With H pointing roughly in the plane, not away, we need to carefully assign RS. In the product drawing, it is on a dash, going back, OCH3 is on a wedge, coming forward, me is to the right, H is at the bottom. Arranging priorities, OCH3, 1, et 2, me, 3, H, 4. H is at the bottom in the plane. Going 1, 2, 3, OCH3 et me OCH3 is front top, it is back left, me is right. This traces a clockwise arc when viewed with H away. We need to check H's position. H is in the plane at bottom, so it's partially toward viewer. The rotation OCH3, wedge front, et, dash back, me, right, appears counterclockwise, giving S configuration. So the product is S,2-methoxybutane. Moving on to the next step. Determine the configuration of the reactant. SN2 reaction proceeds with inversion of configuration, Walden inversion. Therefore, the reactant to bromobutane must have the opposite, R, configuration at C2. Moving on to the next step. Determine which Fischer projection corresponds to R,2-bromobutane. In a Fischer projection of 2-bromobutane, the vertical chain runs top, CH3, C1 to bottom, CH to CH3, C4, with C2 in the middle. Horizontal bonds point toward the viewer. For option, DBR on top. Wait. The vertical axis in a Fischer projection for 2-bromobutane should have the main carbon chain vertical. In option, DBR is on top, me is on the left horizontal, H is on the right horizontal, it is on the bottom. But the top and bottom of a Fischer projection are the chain carbons, me is equal to C1, et is equal to C4, so having BR on top is unusual. Rereading option, D. The central carbon has Br at top, me on left, H on right, et at bottom. Here the vertical bonds, Br top, et bottom, go away from viewer and horizontal bonds, me left, H right, come toward viewer. Actually in option D, the Fischer projection has the chain arranged as top is equal to Br, left is equal to me, right is equal to H, bottom is equal to it. This means the chain is me, C1 left horizontal, toward viewer and at C4 bottom, away from viewer with Br and H on vertical. This seems non-standard. Reinterpreting in option D, the central C2 has top bond to Br, left horizontal bond to me, right horizontal bond to H, bottom bond to it. Horizontal bonds come toward viewer, vertical go away. So, Br is going away, up, it is going away, down, me comes toward viewer, left, H comes toward viewer, right. Assigning RS, priorities at C2, Br, 1, et 2, me, 3, H, 4. Br is going away, back up, H is coming toward viewer, right. With H coming toward viewer, we invert at the end. Going Br at me, Br is at top back, et is at bottom back, me is at left front. The rotation Br, top back, dash at, bottom back, dash me, left front, projecting onto the plane, from top to bottom to left is equal to counterclockwise, so S, but since H is toward us, not away, we invert. Actual configuration is equal to R. And for the final step, R2-bromobutane undergoes SN2 with inversion to give S2-methoxybutane consistent with the product shown. Options A, B, C would give the wrong enantiomer or wrong connectivity. Therefore, the correct answer is D. Therefore, the correct answer is option D.